nothing but the truth. Hello, I'm Raj Chengappa from India Today and your host for Nothing But the Truth. Every week, we will deal with key issues of concern and bring you perspectives and clarity as to why these matter to you and what is the clear truth that emerges. Indian Space Research Organization crossed a major milestone on July 14th when its heavy lift launch vehicle successfully lifted off from the Sriharikota Space Center in Andhra Pradesh. 9 minutes later, it injected Chandrayaan-3, the Lunar spacecraft, into its desired elliptical orbit that will finally take it to the moon. It's a long, lonely distance of more than 400,000 kilometers or 4 lakh kilometers, and it will take the spacecraft Chandrayaan-3 over a month to reach that distance. When it gets to the moon, it will do a circular orbit around the moon at a height about 100 kilometers, and then finally descend and land on the moon. It is expected to do so on August 23rd, after which a compact lunar rover would be deployed on the moon's surface, and it will conduct scientific experiments on space and the moon as well. If India completes this feat, we will be only the fourth nation to do so after the US, Russia, and China. India's last attempt to do so in 2019 was unfortunate when Chandrayaan-2 crashed into the moon's surface and was destroyed. Indian space scientists have, in this interim years, worked on the problem and are confident that they have fixed the landing issue. We are all hoping that Chandrayaan-3 successfully lands on the moon, and that is just a month away or so. So to take us through why Chandrayaan-3 is so important, what is the milestone that it will create, and the significance, I'm delighted to have with us Dr. Anil Bharadwaj, the director of the Physical Research Laboratory, or PRL, in Ahmedabad. Dr. Bharadwaj is an eminent astrophysicist and has not only worked on all the Chandrayaan missions, but has been involved with NASA projects, and including, very interestingly, on the Hubble Space Telescope. His laboratory, the PRL, has several instruments on the Chandrayaan-3, both the landing module as well as the rover. So, Dr. Anil Bharadwaj, welcome to the show, and thank you very much for joining us.
Thank you. Thank you for inviting me to this show.
Anilji, you were at the mission control room at the Sriharikota Launch Center. Tell us what your feeling was when the spacecraft lifted and its significance.
Oh, it was a heroic moment for all of us. You know, this Bahubali of India, the heaviest liftoff vehicle, taking off from Sriharikota, and we could hear the vibrations of it sitting in the control room. We all went out rushing to see the actual launch before we came inside to look at our monitors and see what's happening. And it is so delighted to see this launch going perfectly well. All of you must have seen it across your TV screens.
Yes, yes.
And it has perfectly injected the Chandrayaan-3 in its orbit. So that's the most important aspect.
Well, yeah, I mean, I'm sure it was very thrilling. I was there when Chandrayaan-2 lifted off, and you could see the entire, not only the excitement among scientists, but it is a sound and light show. The roar of the engines, the big flame that comes down that's almost 3 kilometers long, and then finally you watch it on mission control monitors to see whether it's injected. But let's talk about two aspects that are there, Anilji. One is, of course, the landing, because if you recall Chandrayaan-2, there was a problem with the landing. Well, everything else went successfully. It reached the moon. The orbiter was deployed. But then when the lander came, there was a problem. Has this problem been sorted out? And what is the real, if you can say it in a layman's term, what was the issue that caused the kind of crash that happened?
If you look at the Chandrayaan-2 mission as a whole, I will say it is almost like 95% successful. Why I say this is that the orbiter was put into orbit and is still working very well, providing us excellent quality of data. The lander, which was supposed to do the soft landing, it also went on the design trajectory till almost the last kilometer, validating a lot of technologies which have been developed for the landing for the first time in the country. And you know, these landing technologies are not borrowed from any country. Nobody gives it. So you have to design and develop it of its own. So all these technologies which are built in for the first time more or less get validated, except for the last kilometer or so. We now know very well what actually happened, and those validations for and the corrections for which has been conducted in the last 4 years since the launch. And now we are in much robust conditions to handle the kind of dispersions which was seen in the Chandrayaan 2 landing, which would make us do a perfect landing for the Chandrayaan 3.
No, I appreciate the ISRO's perseverance in this, because let's not forget there could have been 100 missions to the moon, but at least there's been a 50% failure, especially for nations that were trying it the first time, whether it was the US, whether it was those days the Soviet Union. Israel tried and failed. China also had its own problems. And we are hoping that India has overcome the issue. The real problem that we found last time, and let's talk about that issue, in the sense that the surface was supposedly a 500 to 500 square meter area, and when it started coming down, it got disoriented, the speed and the velocity was not right, and it crashed. Now, if you take a look at the area that we are planning to land this time, what is the difference between the last time when Chandrayaan 2 tried to land, and what is the difference, the surface difference that is there right now?
In the current landing scenarios, we have relaxed a lot of constraints which was there, including the landing location, which was 500 by 500 kind of situation earlier. It has become about 2.4 by 4.2 kilometers. So it is a much larger landing area in which we allow the lander to land. There are certain changes which has been brought in the lander, the way the lander will function. We have now 4 engines rather than 5 engines. All have been much better placed with respect to the throttles which will be provided by these 4 engines, because the lander is slightly heavier than the Chandrayaan 2. And there are what I call scenarios which have been simulated on the ground to see that we allow larger dispersions of various parameters.
Right.
Now, lander is landing autonomously.
Correct. Yes.
So there is no command and control given from the ground to do anything.
Right.
It is like a onboard computer which is deciding based on the sensors what it is seeing,
Right.
and then taking the correct path. So those kind of dispersions which are allowed earlier have been widened, and not normal or off normal situations of any of the sensors working also has been taken into account, which has enabled us to have a much robust landing than which was there in the Chandrayaan 2.
Well, just to simplify that, what Anilji is saying is essentially that the speed of this spacecraft that is coming down, the lander that is coming down, is close to 6,000 kilometers per hour, which is 6 times the speed of, say, a commercial aircraft. It then has to come and slow down and land virtually at 0 kilometers per hour, with a soft landing. And in doing so, there are many, many parameters, whereas he's talked about as a computer guidance system that allows the spacecraft to come and land. But Anilji, I want to talk about the surface. Now, we are doing this because we also want, it's just not to show the technological competence we have to land a spacecraft on the moon, but also the experiments that we're doing. Can you describe the surface that this spacecraft is landing, and what are the kind of experiments that your laboratory and others are trying to do, and why should we be doing it?
Okay, before that, I think I would like to compliment your channel for taking this on board and trying to explain to the public so that they can also have a better understanding. And I would like to supplement my last answer by telling that Chandrayaan 2 is in orbit around Moon, 800 kilometers polar circular orbit. And it has a OHRC, which is optical high resolution camera. And that has given us much more information about the landing site than we had at the Chandrayaan 2 time.
Right.
So now we are much more equipped for having terrain details than what we were planning and was anticipating at the time of Chandrayaan 2. Now, talking about the experiments on the lander and the rover, there are 4 experiments on the lander and 2 on the rover. More or less, the experiments are very similar to what we have flown on the Chandrayaan-2 lander and the Pragyan rover. And they are essentially meant to understand the new terrain of close to 70 degrees south, where we are going to land for the first time.
Now, is this the dark side of the moon, or the moon has various sides? Is this the first time any spacecraft is being, is landing at this spot, or have there been spacecraft earlier there?
No. So far, if you look at all the landings which has happened from the Apollo to Lunar to Chang'e missions, they are either in the low latitude or mid latitude.
Okay, and what's so
No one
special
has-
about this area that we are going to?
Right. So this is an traveled terrain, I should say,
Uncharted.
or untraveled terrain
Right.
where we are going to land. And that is what I'm telling, that OHRC has played a big role. From the observations on the orbiter, we now know much more detail about the craters, about the boulders around the landing site, and that's why we have chosen a better landing site than what we had in the Chandrayaan-2.
So, if you can describe the landing site, what does the moon's surface look like? I mean, no, we've had astronauts go down. We've actually had a lot of rock come back where we've been able to analyze it, particularly the US and Russia, earlier the Soviet Union. What is the surface that we are now attacking when we take down our, both our lander as well as our rover that Chandrayaan-3 consists of?
Of course, moon consists of craters. And the reason for that is that moon doesn't have an atmosphere or an atmosphere like the Earth. So any body which is coming to the moon will be going and hitting the surface of the moon and producing a crater. So moon is actually full of craters. Now, if you say that if moon is full of crater, how can you do the landing?
Right.
So what we have to do is we have to see a terrain where this cratering process is least, or it is so much that it becomes almost smooth, right? And also we have to avoid any big boulders.
Right.
And this is the work which has been carried out extensively based on the Chandrayaan-2 observations of the optical high resolution camera. Let me tell you that this OHRC instrument on Chandrayaan-2 has the highest resolution camera available on board on any mission so far.
So when you say high resolution, what it means is that it can even, if a number plate is dropped on the surface of the moon, from that distance it's able to even read the numbers and tell you what it's all about. Am I right?
It will give you information up to 25 centimeter.
Wow. Okay. Okay. That's interesting. Now, so when let's talk about the 5 experiments that y'all are doing. 3 are on the lander and 2 are in the rover. And this is, again, a major step that Indian space is taking by not only landing something on the moon, but also having a moving object like the rover get down and do some experiments. So let's start with the lander itself. What are the things you really want to study on the lander?
So on the lander, we have one of the instruments called seismometer.
Seismometer. That's for earthquakes
seismometer.
Or, I mean, moonquakes, if you'd like to call it.
Right. It's a moonquake, or even the meteors which are coming and hitting the moon.
Right.
It produce waves, right?
Yeah.
And that can be sensed by this quite sensitive seismometer.
Uh-huh.
We are also interested to even see whether the movement of the rover on the lunar surface can be captured by this seismometer.
Okay.
The second one is...
Let's just deal with the first one. Why do you want to study earthquakes on the moon? What is the significance of that?
Okay, significance of that is that moon, we believe that there are moonquakes on the moon, which is coming because of the contraction or expansion of the moon.
Okay.
In addition to the external quakes, which comes because of the micrometeorites and meteorite bombardments.
Right.
So if we need to know whether it is external or internal, which can be deciphered by this seismometer because of the kind of signals which is produced when a body from outside comes and hits the moon compared to when it is naturally doing it.
And I would gather the reason why we're doing it is because finally the moon is planned, the lunar surface is planned as a colony for, deeper space probes. So therefore we can come and land on the moon, refuel ourselves with even get water if there's sufficient quantities, and then take off to Mars or any other deep space exploration that we want. So therefore, I would gather that studying the quakes is to see how stable the moon's surface would be, and if you had to land any on that, what is the kind of impact? Am I right? Is that one of the reasons why we study these quakes?
That is one of the reasons, because anyway, if you have to have some kind of habitat on the moon, we need to know it much better before we really start thinking about it.
Right.
And the second thing is that will also help us to understand the rate of meteoroid activities which is happening on the moon, because those are the things which will be detrimental to the habitat itself.
And tell me, how many meteorites bash the moon is it every day? Is it every year? What is the rate?
Oh, it's a very large number which keeps happening all the time. But our idea is to see that can we differ the signals between external quakes formation or the vibration formation compared to internal. And that will be very helpful for us in the future to understand that we have to take care of these kind of activities which happens on the moon.
Okay, let's get to the next experiment that you're doing, and what is the significance of that?
Okay, the second one I'm going to talk to you is an instrument called chaste, or it's basically a thermophysical experiment.
Okay. Can you repeat that word? What is the word you used? Because I didn't catch it.
Instrument name is called chaste.
Okay.
Which stands for Chandra's thermophysical experiment.
All right. Okay. Good.
So essentially, what we are trying to do is, in layman language, we are inserting a thermometer inside the lunar surface.
Interesting.
And putting it to a depth of almost 10 centimeter and measuring the temperature at every 1 centimeter.
Okay.
Now you will say why we should do this.
Why would you do this? Yes.
So the question is that in the Apollo time frames, when human landing happened, they went with big drillers, drilling machines, and they drilled down to almost like 1 meter or 2 meter deep and measured the temperatures. And we have the information about the temperature at the surface.
Right.
In between, we don't have any measurements.
Oh, interesting.
Okay? So that is one aspect. The second aspect is that because moon is constantly bombarded by these micrometeoroids, and it is completely getting churned by this kind of activities, the regolith, or what we call as the lunar soil, is considered as a insulator, thermal insulator.
Okay.
Now, if it is a thermal insulator, how the heat from the surface goes down into the lunar surface? That has to be known essentially in the first few centimeters, because that is the layer which is acting as a thermal insulator.
Right.
And that is why we are putting a probe which will come out from the lander and go inside into the lunar surface and make measurement continuously for almost 1 lunar day and try to give us the temperature profiles.
Now, why is it so important to know the temperature? Is it because we have to put structures there, or what is the reason that it is important for us?
See, I just told you that we need to know how the heat propagates down.
Right.
There is the temperature measurements at the surface and a temperature measurements something like 1 meter or 2 meter deep.
What is the temperature on the moon? What is the temperature currently? If from whatever studies we know, what is the average temperature that's there as compared to the Earth, if you look at it?
Okay, if you go to the equatorial regions, the temperatures can be almost like 400 Kelvin. That is something like 100 degrees centigrade.
Wow.
More than the boiling point of water, right? Wow. And if you go to the night side, it could be 50 degree Kelvin.
Right, which is freezing temperatures.
Right. So almost like 300 degree temperature change happens from day side to night side.
Wow.
Okay.
And your night and day and moon is what? 14? It's not like 24 hours. It's 14 days, I would gather, right?
14 days day, 14 days night,
And that's why when we land this rover and this landing module, we have only 14 days to do the experiment, because that's the time it's day. And once the night sets in, you're saying the temperatures are, when you say 50 degrees Kelvin, what would you say is minus how? 200 degrees, minus 50 degrees centigrade? What is that temperature you're talking about?
So we are talking about something like minus 50 degree centigrade kind of thing.
Wow. Okay. So it's freezing, and that means all your instruments will get completely
Yeah.
destroyed. So, okay, you
Right.
have this 14-day window, and that's why you're landing on this day. So, the second experiment you've talked about, what is the third experiment?
Okay, the third experiment is called Ramba, or it is basically a Langmuir probe.
Right.
It's a probe which will give us information about the plasma distribution around the landing site.
Okay.
Because it
Plasma
is
meaning what? The atmosphere, or what
now,
is it?
plasma means it will give you information about the electrons and ions.
Oh, okay.
Okay. Now you will say that I just told you that moon doesn't have an atmosphere. So how can you have an ionosphere?
Right.
But moon does have a very tenuous atmosphere, which we call as exosphere.
Okay.
Exosphere is a region where atoms and molecules don't collide with each other.
Right.
Essentially because the main field path is much larger than the scale height. So that means there is a small amount of gases present, but their abundances are very, very low, very, very low. Okay, almost like 15 orders of magnitude lower than the air which we are breathing currently. Okay.
Right.
Now, at this kind of low pressures also, you can have ionization of this because the solar radiation is coming, and solar electromagnetic radiations, which consist of extreme ultraviolet photons, can ionize these
So,
atoms
why
and
is
molecules.
that important? I know this is high science, but in a layman's term, why should we study this plasma? What difference does it make to whatever we're doing over there?
Okay, so simple reason is that this will also be very important for us to understand if we have to have habitat on the moon. Why? Because the plasma distribution is the one which will decide a lot of properties of the gadgets, about the equipments, and the process in which we will be doing the habitation.
Okay.
You must be hearing about this, that there's a radio communication breakout because of ionospheric
Right.
disturbances the earth, right? So we don't want that kind of
Acha, to
to be happening on the moon when we have a direct connectivity and humans living, right?
right. Very
And you
interesting.
can
Very
also
interesting.
imagine about mobiles working on the moon,
Yeah,
right, in the
that's
future,
true. We know what will
right?
happen on Earth if that happens. But we've got
Right.
only about 3-4 minutes left, Anilji, and I want you to talk about the rover experiments. I mean, this is new. You've got this vehicle going, compact vehicle going on the surface. What are the experiments you're hoping to do, apart from saying that, okay, we've driven a vehicle down there and moved it around?
Okay, on the rover, of course, the technology you have just explained that we need to see how the rover moves on the lunar surface after it is unclamped and come down on the rail or the ramp. We need to go around the landing site only because the rover is going to communicate with the lander and the lander communicates to the ground. The experiments on the rover, there are two of them. One is called alpha particle X-ray spectrometer.
Okay.
The
That
second
sounds like
one
a lot
is
of rocket science, but if
no,
you can
I will just explain you very
very
simple
simply
language.
why it's so important. Yeah.
Right, I will explain you. And the second one is called laser-induced breakdown spectroscopy or LIBS.
Wow,
Okay.
that's a mouthful.
Now, both these instruments are essentially trying to get the elemental and mineralogical composition
Okay.
of the surface.
Interesting.
Now, why we should be knowing it? Essentially because we need to know at what level of scales this kind of composition of the moon changes. Now we are having a rover which is moving on the lunar surface somewhere around a kilometer around the landing site. We are getting a ground truth information from the rover and your orbiter, which is already in the orbit,
Right.
the two, is providing us this information from 100 kilometers.
Right.
So it has a much wider coverage. It is something like a few kilometer observations. It gives you that these kind of minerals, these kind of elements are present there. But when we land, we want to measure and see what our orbiter is giving, right? And this will help us to understand the subtle small changes or variations which will be present on the lunar surface. And this is going to be also very important for us when we are talking about future landings on the moon surface and exploration. Because if we have to make habitat on the moon, we should know what kind of minerals are present there and how does they vary. If they are varying within a meter, or within a kilometer. That means we should land to a region where we need to know, we need to get those kind of minerals which is present there, right? And that is why it is very important for us to have this kind of information, which is possible only when you land and move around onto the lunar surface.
Anilji, we're out of time, but this was fascinating to listen to you. We now understand the significance of why India is doing it, the importance of it. Let's not forget that there's only 3 other nations that has done it so far. India is going to be the 4th nation, hopefully, on August 23rd when it lands its module over there, as well as Anilji, I'm sure you must be praying that not only does it land properly, but also the rover comes out and all the 5 experiments, which you probably would have taken years to put together and, of course, couldn't do so in Chandrayaan 2. All those hopes rest now on this particular thing. Let's wish all of you all good luck and success. And we are waiting with bated breath for the kind of information, not only in terms of the landing, but also the scientific significance of these things that it would provide India. Thank you very much, Anil, for joining us from the Space Center in Sriharikota live. Thank you so much.
Thank you. Thank you so much, Raj, for talking to me. Thank you.
Thank you for being with me on this show. I look forward to having you with me next week. Nothing but the truth.